Back everyone to my channel. In this video, we are going to see chapter 7 integrals exercise 7.1. Okay, so first of all, we required some formulas to solve these, and the formulas are integration of x power n dx is x power n plus 1 by n plus 1 plus c. Integration of 1 by x dx is log x. Integration of constant into dx is constant into x dx, or integration of 1 dx is x plus c. Sorry, this is plus c. And the next one is integration of cos x dx is sine x plus c. Integration of sine x dx is minus cos x plus c. How do we get this is differentiation of cos x we get as minus sin x, whereas integration of sin x we get as minus cos x. Okay, integration of secant square x dx is tan x plus c. Integration of cosecant square dx is minus cot x plus c. Integration of secant x tan x dx is equal to secant x plus c, and integration of cosecant x cot x dx is equal to minus cosecant x plus c. These are the formula list which we have to keep in our mind before going on to the exercise 7.1. And if we see the important questions of this exercise 7.1, first 1 to 5 problems all are important for 1 marker, and then from 6 to 20, 7th question, 8th question, 9, 11, 12, 15, 17, 18, 19. These are the important questions of exercise 7.1. Okay, let's start with exercise 7.1. Find an antiderivative or integral of the following function by the method of inspection. Method of inspection is since first we have to take the function, that is we have to differentiate some function to get this function. Okay, so we clearly know that differentiation of cos is sine, so cos 2x we get as minus sine 2x. Using chain rule, if we take 2 into 1. Okay, now we just need sine 2x alone, so take all other thing on the other side. So if we take on the other side, we get sine 2x is equal to d by dx of minus, if we take minus, and this 2 1 by 2 cos 2x. Okay, on integrating on both the sides, we get integration of sine 2x dx is equal to integration, and this d by dx gets cancelled, so we get minus 1 by 2 cos 2x plus c. Okay, this is the method of inspection. So second question is cos 3x. Differentiation of sin x we get as cos x. Differentiation of sin 3x we get as cos 3x. Chain rule now. Sin 3x is cos 3x into 3. Differentiation of x is 1. We just need cos 3x. So cos 3x is equal to differentiation of this 3 goes on the other side, 1 by 3 sin 3x. Okay, on integration, integrating on both the sides, we get integration of cos 3x dx, which is equal to 1 by 3 sin 3x plus c. Okay, now we know exponential. The differentiation of exponential, if it is d by dx of e power x, d by dx of e power x is e power x itself. So we can take d by dx of e power 2x itself. So we get e power 2x into chain rule. Here also we have to use into 2. 2x is 2 into x is 1. Okay, e power 2x we need. So e power 2x one side, if we have e power d by dx of 1 by 2 e power 2x. On integration, integration of e power 2x dx is equal to half the e power 2x plus c. Okay, so we know in differentiation power rule, if it is x power n, d by dx of x power n is x power n minus 1, right? So if it is x square, we get x, right? 2 minus 1 is 1. X cube, we get x square. 2 n x power n minus 1, 2x, 3x square. So we can clearly see the power is 2 here. So now we would got an idea, like I guess you would got an idea to take that the function as ax plus b, but we just have to increase the power by 1, that is 3. Okay, so now if we differentiate, first is power and then this function, chain rule, according to chain rule. 3 into ax plus b the square, 3 minus 1 is 2, into a is a constant, differentiation of x is 1, plus differentiation of a constant is 0. Now d by dx of ax plus b the whole cube is equal to 3 ax plus b the whole square into 2. We just need ax plus b the whole square. Take all other terms on the other side. Ax plus b the whole square is equal to d by dx of 1 by 3a comes on the side. Ax plus b the whole cube remains as it is. Integration of ax plus b the cube square is equal to 1 by 3a ax plus b the whole cube plus c. Okay, the fifth question. Here if we see there are two terms, sine 2x and 4 e power 3x, right? So first we'll take the single term. First we'll find the integration of the first term and integration of the second term using the method of inspection. Okay, so if we do so, first we take sine 2x. If we take sine 2x, differentiation of cos 2x, we get sine 2x, we know. So first differentiation of cos 2x is minus sine 2x into 2. Only sine 2x we need. So sine 2x is equal to d by dx of minus 1 by 2 cos 2x. Okay. And then it is e power 3x. E power 3x, if we have to find or if we have to get it, e power 3x will take. So it is e power 3x into 3 and we just required 4. So multiply 4 on both the sides. If we multiply 4 on both the sides, 4 e power 3x we get is equal to 4 e power 3x into 3. Only these terms we need, so all other thing we just send on the other side. If we send d by dx of 4 by 3 e power 3x is equal to 4 e power 3x. And here if we integrate on the both the sides, we get integration of sine 2x dx is equal to integration, and this d by dx gets cancelled. Remaining is half cos 2x plus c. And here on integrating both the sides, integration of 4 e power 3x dx is equal to, this integration and d by dx cancels, we get 4 by 3 e power 3x. So this can be written as integration of sine 2x minus 4 e power 3x dx. Separately we can take, if in integration we don't follow any product rule or divisibility rule, only if it is addition or subtraction we can integrate it separately, but for product and division we can't do anything. And in further exercise and all, we'll see the solution for those. We have so many methods of solving for those and all. Okay, first let's see this. Sine 2x dx minus integration of 4 e power 3x dx. So the answer would be minus half cos 2x minus 4 by 3 e power 3x plus c, e power 3x. X is for this 3. Okay. Now let's see the sixth problem. Now we just don't have to use the method of inspection and all. Directly we can integrate. And for to integrate this, I've already given the formulas at the beginning itself. If you don't remember, just take a look at that and then skip here. Okay. First, integration of 4 e power 3x plus 1. We can just divide it as 4 e power 3x dx plus 1 dx. Integration of 4. 4 is a constant, 4 we keep as it is. And then integration of e power 3x is e power 3x and the coefficient of x is 3. We have to divide the term by its coefficient plus integration of 1 is x plus c. And then the seventh problem, integration of x square into 1 minus 1 by x square dx. Okay, as I have already told, there's no product rule or divisibility rule in this integration. We just have to multiply inside everything to do this. Integration of x square minus 1 by x square into x square dx, right? These x square gets cancelled, where we can write as integration of x square dx minus integration of this 1 dx. We get integration of x power n. Integration of x power n is x power n plus 1 by n plus 1 plus c. X square 2 plus 1 by 2 plus 1 minus integration of 1 is x plus c, which is x cube by 3 minus x plus c. And then the eighth problem, integration of ax square plus bx plus c dx. So now I'll just do it directly. Now integration of integration of ax square dx plus integration of bx dx plus integration of c dx. Here a, b, c are the constants. Okay, so integration of constant is x. We know constant alone is x. Now a comes as it is x square, as we have already seen, x square is x cube by 3. So x cube by 3 plus integration of p is p itself, x is x square by 2 plus integration of c, constant is constant, into x plus c. Okay, and then the ninth problem, integration of 2x square plus e power x dx. Okay, now integration of 2 2x square dx plus integration of e power x dx. 2 is a constant. Integration of x square is x cube by 3 plus integration of e power x. Coefficient of x is 1. Divide the term by coefficient of x. Okay, so plus c. And then the 10th problem, integration of root x minus 1 by root x the whole square dx. Here we just use and also we don't use any chain rule in this integration and all. So there's no proper thing like formula to do this. Like if it is differentiation, first we would differentiate the power and then the inner function, but there's no chain rule here. So if it is x power n, we can use this formula. There's only one term, we can use this formula, but there are actually two terms. So we'll just take a minus b the whole square formula. Here we can use this, right? A minus b the whole square is a square plus b square minus 2ab, which is a square, where this is a and this is b. A square plus 1 by root x the whole square is b square minus 2 into a is root x, b is 1 by root x, and these cancels. Integration we have to keep as it is, dx also it is written. Yeah, square root get cancelled, we get x. Square root cancel, 1 by x minus 2 dx. So as we can observe, it is like power and all. But here we have got the simplest one, which is x 1 by x minus 2 dx. Okay, so we know integration of x is x square by 2, x square by 2, and this is x to the power minus 1, right? This if goes to the numerator, it is minus 1. Integration of 1 by x is log x minus integration of constant is constant into x plus c. The 11th question, integration of x cube plus 5x square minus 4 by x square dx. Divide each term by x square dx plus integration of 5x square by x square minus 4 by x square. Okay, now we can see we can cancel it. So there will be 1x left out. These two x's gets cancelled. Where we get integration of x dx plus integration of 5 dx minus integration of 4x to the power minus 2 dx. If it is integration of 1 by x, we can write as log x. But if it is integration of 1 by x square, we can't use logarithm to write that. Okay. Now, integration of x is x power 1. 1 plus 1 is 2 by 2 plus 5x minus 4. Minus 2 plus, sorry, x to the power minus 2. X to the power minus 2 plus 1 by minus 2 plus 1. Where we get x to the power minus 1 by minus 1. It is minus 1 by x plus c. X square by 2 plus 5x plus 4 by x plus c. Now this 12th question. X square plus 3x plus 4 by root x dx. The same we are going to use here. What we have did, dividing each term by the denominator. Same. Divide each term by the denominator. X square. This is half, right? Root x can be written as x to the power half. So 1 by root x can be written as x to the power minus half. Minus 1 by 2 plus 3x power 1 minus 1 by 2 plus 4 into x to the power minus half dx. Now 3 by 2 plus 3 1 by 2 x to the power 1 by 2 plus 4 x to the power minus half dx. Same x power n formula we have to use. X power integration of x power n is x power n plus 1 by n plus 1 plus c. Okay, so now x power 3 by 2 plus 1 by 3 by 2 plus 1 plus x 3 x power 1 by 2 plus 1 by 2 plus 1 plus 4 x to the power minus half plus 1 minus half plus 1 plus c. It is x to the power 5 by 2. If here it is 5 by 2, 5 will be in the denominator, 2 will be in the numerator, plus 3 x to the power 3 by 2. And here 3 by 2, 3 in the denominator, 2 in the numerator. So 3 into 2, 3 cancels here. And 4 x to the power half by 1 by 2. 2 goes to the numerator. So we can write as 2 by 5 x to the power 5 by 2 plus 2x power 3 by 2 plus 4 2s are 8 x to the power half plus c. And the next problem is 13th one. Integration of x cube minus x square plus x minus 1 by x minus 1 dx. See here in the denominator there was only one term, but if we see here it is x minus 1. There are two terms. If it is like this, we can't do anything. So the one method is we have to find for x minus 1. Here x minus 1 is there, but can we find x minus 1 here? Yes, we can find it. So that is, if we take x square as common here, x square into x is x cube. So x minus x square, if we take out 1 is common, plus x minus 1 whole divided by x minus 1 dx. Okay, x minus 1 dx, which is equal to integration of, for this we'll take this as one term and this as one term. Divide these two terms by x minus 1. Okay, so if we divide it, x square x minus 1 by x minus 1 dx plus integration of x minus 1 by x minus 1 dx. X minus 1 gets cancelled. Here too x minus 1 gets cancelled. So it turns to be integration of x square dx plus integration of 1 dx. See here how complicated it looked, but how simple it turned, right? So nice it is. So integration of x square is x cube by 3 plus integration of 1 we know it is x plus c. This is the answer. Next 14th question is 1 minus x root x dx. As I have told, the root x can be written as x to the power half. So we are just multiplying this inside where we get integration of root x minus x to the power 1 plus half dx. Okay, now integration of half is integration of root x is x to the power half plus 1 by half plus 1 minus x power, it is actually 3 by 2. This can be written as x power half minus x power 3 by 2 dx. X power 3 by 2 plus 1 by 3 by 2 plus 1 plus c. And here we can write as x to the power 3 by 2 and 3 2 in the numerator minus x to the power 5 by 2, 5 in the denominator, 2 in the numerator plus c, which can be written as 2 by 3 x to the power 3 by 2, 2 by 5 x to the power 5 by 2 plus c. Okay. And the next one is 15th question, integration of root x 3x square plus 2x plus 3 dx. Multiply each term by root x. Take root x inside the bracket. 3x square plus half plus 2x power 1 plus half plus 3x to the power half the whole dx. We get integration of 3 5 by it is actually integration of 3 x to the power 5 by 2 plus 2 x to the power 3 by 2 plus 3 x to the power half the whole dx. Okay, now we just solve this integration. 3 is a constant, x to the power 5 by 2 plus 1 is 7 by 2 divided by 7 by 2 plus 2. X to the power 3 by 2 plus 1 is x to the power 5 by 2 by 5 by 2 plus 3 x to the power half plus 1 is x to the power 3 by 2 by 3 by 2 plus c. Now this 3 gets cancelled and this 2 goes to the numerator, which we get 3 2s are 6 by 7 x to the power 7 by 2 plus 2 2s are 4 by 5 x to the power 5 by 2 plus x to the power 3 by 2, 2 x to the power 3 by 2 plus c. Then the 16th problem, integration of 2x minus 3 cos x plus e power x dx. So there's no project or there's no numerator denominator. We can just integrate it directly. So integration of 2x is 2, integration is 2 itself, and then integration of x is x square by 2 minus 3. Integration of cos x is minus sine x plus integration of e power x is e power x plus c. Okay. Now minus into minus is plus, 2 gets cancelled. We get x square plus 3 sine x plus e power x plus c. Okay, 16th one. Next is the 17th problem. 17th one, integration of 2x square minus 3 sine x plus 5 root x dx. Okay. So now integration of 2x square is 2x cube by 3 minus 3 integration of sine is cos x plus 5. Integration of x to the power half is x to the power 3 by 2 by 3 by 2 plus c. We get 2 by 3 x cube minus 3 cos x plus 5 2s are 10 by 3 x to the power 3 by 2 plus c. Now 18th one. Integration of secant x into secant x plus tan x dx. Okay, so here it is a product. So multiply each term by secant x, we get integration of secant square x plus in, secant x tan x dx. Okay, so now we can integrate each term separately. Integration of secant square x is tan x plus integration of secant x tan x is secant x plus c. And then 19th one is integration of secant square x by cosecant square x dx. This secant square x, we know secant x is equal to 1 by cos x and cosecant x is equal to 1 by sin x. On substituting these two, we get integration of secant square x is 1 by cos square x into cosecant square x is 1 by sin square x dx. Okay, so this is sin square x by cos square x dx, and sin x by cos x is tan x, we know, right? So integration of tan square x dx. We know the identity, which is tan square x plus 1 is equal to secant square x. So tan square x is equal to secant square x minus 1. On substituting this here, we get integration of secant square x minus 1 dx. Integration of secant square x is tan x minus integration of 1 is x plus c. Okay, and then the 20th one is integration of 2 minus 3 sin x divided by cos square x dx. Divide each term by cos square x. So if we divide each term by cos square x, we get 2 by cos square x minus 3 sin x. Here I will write this cos square x as cos x into cos x dx. Okay, now why did I write like this? So the reason is, we know 1 by cos square x is secant square x, right? So where we can write this term as 2 secant square x minus 3. We know sin by cos. This term sin by cos will become now tan x, and here one more 1 will be left. Okay, 1 by cos x we can write as secant x. Okay, now we can integrate this. If we integrate, 2 integration of secant square x is tan x minus 3 integration of tan x secant x is secant x plus c. If we see 21st problem, it is the antiderivative of this, and they have given 4 options. Antiderivative in sense the integration of root x plus 1 by root x dx. We know integration of x bar half. X bar half is x to the power 3 by 2 by 3 by 2 plus x to the power, okay, 1 by root x is x to the power half divided by half. How do we get this is x to the power minus half we write. Okay, x to the power minus half, integration of x to the power minus half plus 1 by minus half plus 1. Minus half plus 1 is x to the power half by 1 by 2 plus c. And this is 2 by 3 x to the power 3 by 2 plus 2x to the power half plus c. The second just says that the differentiation of the function is 4x cube minus 3 by x bar 4 such that the function at 2 is 0. Then we have to find the function at x. Okay. So if we take differentiation of the function is 4x cube minus 3 by x bar 4 on in integration the integration d by dx of f of x is equal to integration of 4x cubed minus 3 by x power 4 dx. These two gets cancelled. So f of x is equal to integration of 4x cubed is 4. 3 plus 1 is 4 by 4 minus 3. X power 4 we can take to the numerator as x to the power 4 minus 4. X to the power minus 3 by minus 3 plus c. This 3 cancel, 4 cancel. X to the power 4 plus minus into minus is plus 1 by x cube plus c. And we found f of x, but we don't know this constant because there are two options which just says the same. X power 4 plus 1 by x cube, and here minus 129 by 8 is there, but whereas here plus 129 by 8 is there. They have just clearly given out that f of 2 is equal to 0. So f of 2 is, at the place of x we should substitute 2 to the power 4 plus 1 by 2 cube plus c, which just says it is equal to 0. So 2 power 4 is 16 plus 1 by 8 plus c, and 0 is equal to 128 plus 1 by 8 if we take LCM plus c. If we take this whole term to the other side, it just becomes c is equal to minus of 128 plus 1 by 8. Okay, so c is minus 129 by 8, and if we substitute c here, we just get x to the power 4 plus 1 by x cube minus 129 by 8. So our option is C. Thank you for watching this video. See you all in the next video. Bye.